All right, excuse me, let's take a look at a few. Join the Zoom session if you would, and then I'll have a couple of people take over so we can see their Visio data flow diagrams. Remember, a data flow diagram is just the boxes. It does not show logic. It only shows what modules call what other modules. So it's an important tool in designing our applications, but it's not something that shows how logic works. So if you're trying to add that in, don't do that. All it should show is this data goes into this module and what output comes out. So does anybody have one they want to show us? Let's share here. I know we've got some good ones around. Let me find someone. Wrong list. Like, that doesn't look like anybody's names in here. Aaron, will you share since you were already helping Brittany get caught up here? Our out-of-towner. You what? I felt like I woke up from a coma when I came back. I'm like, I don't know what's going on. I bet. Screaming outside. I was going to say, I feel that way this morning from all the allergy. Oh. Too many allergy pills for sure. I probably have it hidden somewhere. Let me see what I can find. There we go. That looks better. I was still sharing too, so I was overriding. Ooh, good pick on my part. That looks really nice. Tell us about it, sir.
So I just kind of set it up with some simple text. So the main module was kind of having that universal data with the dealer and shipping chart that don't change, and then each module is returning different input from the user for review. So like gather info, you get name, car make, base price, engine choice and cost, trim choice and cost, radio choice and cost. And then all of those are going, a lot of that's taking that data and then putting it into calculations. And those calculations are out for the selling price. And then that selling price is getting put into the return output along with the name and car.
It's good. What do you think? The one that I'm concerned about, I think it looks really good. And I like the way you put the data to the side and kind of organized it with the boxes, because some of the examples in our book even are a little haphazard, a little unorganized, because data flow diagrams are kind of not really standardized. But one question, is our output module really going to be called by our calculations?
I guess it'd be coming off the main.
Yeah. Is it coming off the main?
I guess, yeah, the calculations, I guess, would be going back to that, and then.
Yeah, see if you can drag your output, because I think it should be more in line with your other modules here. And then you should be able to take that line and just disconnect it from your calculations box and connect it to your main instead. Delete that one. Just Visio trying to help you out, I see. And one thing that we found over the years, if you right-click on that line and change its color, then Visio won't collapse it down into the other lines because it's like a different color. So that's kind of a way you can trick Visio into not doing that. Because you should try creating a network diagram with 76 of those little lines that all want to collapse together, and then you can't tell anything that's going on. I'm gonna let you do it. I just right-click on that line and make it just a little teeny bit of a different color, and then just move it around it and collapse. You can do that however you want. The colors kind of help emphasize where things are called from too, don't they? So think about it, if you were using Visio and you were really trying to explain some sort of flow to somebody that was having a hard time understanding it, and you really needed them to understand it to make sure that you had it correct in your mind, you might want to color code things like that so that they would really visualize what's going on. Because remember, we might not want this exact diagram to show to a user or someone that's helping us design, but we might. This might be exactly what we need to convey to them what's going on. So really good. Let's give Aaron a hand. I've mangled up his data flow diagram. Yay. Very good. Does anybody else have one they would like to share? I can call on you. Let's see. I know Garrett was just working on his. Haley, do you have one? I'm going to pick on the back row today. Is yours ready? I don't want to put you on the spot, but I know it's always looking good back there. Colors, yay. Okay, tell us about what you've got here.
There's and then all the choices.
Notice how with Haley's the calculation is kind of in between some of these other modules. That's okay, because remember our data flow diagram isn't trying to show any sort of logic, only what module calls what other modules. So it doesn't matter any order, just so long as they're hanging off of the right thing. And we all know, after fighting with Visio lines for a little while, how hard that can be. It looks really good. Let's give them a hand, yay! Great job, you guys. I'm gonna share my screen. I know we have a lot of people in here that work really hard to get here and all of that stuff. I appreciate that. Let me know if you have any questions with anything, as always. And remember that sometimes if it seems like I'm pushy or wanting you to do something that you don't really like to do, or expecting you to really research some things, it's because I want you to be successful. And I don't know, did I tell you about that guy that got hired a few weeks ago out of our CIS program? He has 2 years in college, right? He got his associate's degree. And he got hired a couple weeks ago by a company in Springfield, and he's making $60,000 a year. Did I tell you? Yeah. How much is that?
What company was it?
I can't remember the name of the company. It's not a big one. It's a small company, so that's why it's super surprising that he got so much. He was, you know, I mean, he's a really super good student. I'm going to bring up this calculator, and I'm going to do 60,000 divided by 52 weeks in a year. That's 11.53 a week. Let's divide that by 40 hours in a week. So almost 30 bucks an hour. That's really good for coming out of a 2-year college. The reason that that happens is because sometimes as instructors at OTC are cut out, right? And that's why those employers were willing to give them that kind of money. So we want to make sure that we are always keeping our end in sight and remembering that if I'm throwing something at you and saying, go Google it, well, that really annoys people when I do if I do that to you, it's because that's what you're going to have to do when you get out there and there isn't anybody else necessarily to ask, and I want you to have those skills and know, oh, I can just go search and find something and I'll be able to figure this out. Because that's what we want for everybody to be able to have. You know, when someone said, money isn't everything, that wasn't this semester, it was last semester, someone said that when I was talking about how much money someone made. It's not everything, but boy, it sure does seem like everything if you don't have any of it, right? So it kind of is all relative to how much you've got. I think if you have a ton of money, you can just walk around saying, money doesn't matter, shoot. But then, you know, sometimes it does matter a lot. All right, so you guys have some data flow diagrams down. You hopefully are getting a good feeling for how those are different from flow charts. Here is a flow chart for a program that we haven't written. We're going to write one here soon in a few minutes that will look somewhat like this, but I wanted to show you an official flow chart that was calling functions or subprograms. So this program uses a function called calcsum to calculate a sum of two numbers. Then it outputs the sum and the two numbers. So it has the main method, or the main function, calls four other functions. Input num, it calls twice. Then it calls calcsum, and it calls out info. So this is the main flow chart. Notice that the process box has lines added to it. That means that this is a module or a subprogram in the flow chart. Now, because there's a subprogram in the flow chart, I've added sections for those subprograms. So here's our input num function. At the top, I'm showing the function name. At the bottom of the flow chart, we're showing what kind of output data is returned from that function. All that our input num function does is prompt the user for a number. Now our calcsum function asks for two numbers as parameters, as input. It uses those two numbers to calculate the sum, and then it returns the sum back to the caller. So that's all it does. It's like one line of code in that function. Our output info has three parameters. It wants the original two numbers and the sum, and then it just outputs that information to the user. So as you're a beginning programmer with some of the beginning programs that we write, this seems like craziness. This is like overhead to call all these functions when we just only have like one line of code here. Why do we go to all that trouble? Because it's logical, and we want to modularize our code so that when we get to things that are bigger and much more substantial, we'll already be used to writing logical functions for things. We'll be used to pulling things out. Now, with this setup, if someone came along and said they wanted this change XYZ to this program, like if they wanted some differences in the output, we would just be able to go to that output info function and modify it and not really affect the rest of the program. So we're kind of isolating our code. That code isolation is a really important concept because we're saying that we only want each function to do one thing and have its own purpose in life. So this is just how you would do a flow chart if you were adding in functions to it. So you can see that flow charts are tools that work really well for small programs, and as programs get larger, they start getting really out of hand. So you won't see a lot of flow charts on great big giant programs. Last time we were looking at the PowerPoint from the textbook. There's a few more things to talk about in there. When we're passing these parameters into a function, the input to the function, we can actually pass things in two ways. Let's draw a picture up here. I have function 1 and function 2. And in function 1, I have a variable we'll call it A, and it's located in memory. So let's say our A value has a value of 11. Now, when we pass this variable A from function 1 to function 2, passing A, when we pass A to function 2 is going to do something to A. Let's say it's going to say A equals A plus 45, and then it's going to be done. It's not going to return any value or anything. Just update the value of A. Whenever we return then to function 1, the value of A in function 1 will be unchanged. And that's because this number, this variable, was passed by value. So when we're passing by value, the system actually creates a copy of this variable to give to function 2. Function 2 updates it. Now it's equal to 56. And then when it returns, function 1 still has its own original copy of this A variable. It hasn't been updated. So these are both local variables, local in scope. They only exist within the function that they're defined in. Now, there's another way that I could do this that's not really as possible in Python. So it's kind of an older way. I can pass by reference. This happens automatically for us with some programming languages, and sometimes we have to actually do things, special syntax to tell it to do this. Now, if I'm passing by reference, when function 1 calls function 2 and says, I want to pass you this variable A, instead of function 2 getting its own copy of the variable A, the system is going to say, oh, A is over here, and point to the exact same place in memory. Now when function 2 updates our variable, that update would be in effect in both functions. We would see that update in our calling function. That's called passing by reference. When we pass by reference, we don't copy the data for the function that we're calling. We just add a pointer to the memory location where the data exists in RAM so that the function is using the same exact copy of the variable. So as you get more experienced in programming, it'll start actually being something that you can implement and think about it. Remember that as we go through the semester, you're in an introduction. If you were going to school to be a doctor, in the introduction to doctoring class, you would not expect to know every single thing about being a doctor when you got done, right? Same is true about the introduction to programming class. You should be able to memorize some of these terms and answer questions, but there may be some things that don't make deep sense to your brain until you've had more of an opportunity to experience it. Again, you can't expect to be the know-all, be-all programmer from the intro class, just like you can't expect to be the doctor from the intro to doctoring class. So get as many of the concepts down as you can, and remember that you're going to revisit all of these in other programming classes, not the only one. So you take C#, these things will be mentioned again. We've given opportunities to try different examples with them. So value parameters, changing the values in a subprogram does not affect the value of the corresponding variable in the calling, and reference parameters does affect, because we're just looking at that same position in memory. Now, whenever we're passing by value and that copy is made, that's really our only option with Python. That's just how it's going to do it. Whenever we get to arrays next week and we're looking at arrays in Python, those will actually automatically be passed by reference, because an array is a list that can be kind of big, and Python's like, I'm not making a copy of that. I'm just going to point to it. So things will happen internally that we won't even necessarily be aware of. Now, here's an example program. In this one, they're passing by val. So whenever we're looking at things, Oh, they actually have two. In this example, pretty much it's pseudocode, but they're saying it's kind of a little bit like C also, but they're saying they want to declare two numbers, it's integers, and then they set those values for those numbers. Then they call the switch it function. Now in our switch it function, it says it wants to receive number 1, so my number will become the value for number 1, and it wants to receive number 2, so your number will become the value for number 2. Now number 2 is being passed as reference, so both of these functions will be sharing the same version of that variable. They will not be sharing this first variable. So when we update number 1, it will be only updated within the switch it function. When we update the variable number 2, that update will impact our main method also because it was a reference variable. Now some other functions that we have are built-in functions for the system, and you guys have been using some, and I've heard people suggest some others because you're on it. We've used the string function a lot in Python, right? When we want to make something be able to be output with our print statement. We've also used the int function a lot where we want to convert something to an integer. The other functions that they mention a lot in our book are things like to upper and to lower and all sorts of general ones. Let's take a quick look at this function sheet. We'll just give you a couple of minutes here to do some research. And for each of these built-in functions that our book talks about, I'd like you to find the same exact function for Python. Python is going to be a little different. I know we don't usually use things that require pencils, so there's a bunch up there if you need one. Not a problem. So this is not super fancy. Just figure out, let's see, for the SQRT function, the square root function that our book talks about, what is the Python built-in function for that? Glad I stole all those pencils last week.
I'm sorry, I had to steal one of your pencils.
That's all right. I don't care, I stole them. Okay, looks like everybody's about done. Good job. What do we need to do to use the square root function in Python? We have to import math. What does that mean when we import math? That means copy the math library into this program, right? And that math library has a bunch of Python code in it. You could write Python code and create your own library like that if you wanted to, of different functions that are available for people to call. So whenever we say import math like that, we're saying we want to copy in that system library of system functions, built-in functions. So the math library has a series of built-in functions. We can then use those built-in functions. So to call the square root, we're going to start out with that keyword math. It's going to make it uppercase for me. And then what would the function name be that we would want to use to calculate a square root? SQRT. And then within the parentheses, we would pass in some value. So for the does section, I'm going to say this calculates the square root of x, right? Because that's what I'm passing in. What about the int function? How do we do that in Python? Is it the same? Is it int?
Yeah.
Int. And then again, we would pass the variable in that we want converted to an integer. So let's say converts x to an integer. What about the ceiling function? So we need that math library. And then what's our function name if we're in Python? CEIL. And again, we're going to pass it the data that we want affected. What's the ceiling do? Not less than what? Ceiling?
Yeah, that's what I found too.
Huh?
That's what I found too. I thought it sent a message stuff,
That's what I'm thinking.
but like that's the one that I found too. And then Laura will say that.
Where did you look?
I'm on a website called Tutorial Point.
That should be a good one. What's it say? What's it say? Same thing.
Mine says return ceiling value of x, the smallest integer, not less than x.
The smallest integer, not less than x. So let's look at this function. We should try it. We'll try it and see how that works. Because that's, I'm sure makes perfect sense, but I'm not getting it this morning. So I'm going to put that in. It changes basically a float to a decimal. The value is not less than x. But this one rounds up. So we're going to try some of these. Now, what about floor? We still need that math library. And what's our Python function called? Still floor. And what about it?
And the largest integer, not larger than
The largest integer, not larger than x. What about random? Do we need to copy in a library, import a library? Our random library. And so we'll have the name of our random library, and then what's our Python function to generate a random number? Rand int. Now I'm going to leave x out of this equation, right? Because the random number is going to be generated is an integer. What about the length of function? What did you guys find in Python to use? And I'm going to put S within our parentheses instead of X because the length of is usually looking at a string, right? So in our does section, I'll say that it gives us the length of our string, S. What about to upper? Now with Python, we would have to put the string name first, and then we would do a period, and then we would put our upper function call. That would return the uppercase value of S. We could also do it as str dot upper passing S in as a parameter. So Python kind of actually gives us a couple of ways to do that. In this way would have empty parentheses. Now, the to lower, what's our Python function name? Lower. And again, that gives us the lowercase value of S. And we could also do str dot lower and pass in S as a parameter. So we have the flexibility. Our last one is val. What's val do?
I didn't get that far.
Well, val does absolute value. So basically,
There's no such function in Python.
oh really? Well, Google's just wrong, huh?
They're all
So we would use the ABS function for the absolute value. So there is no val function. Google's right about that because they made it the absolute value function. Silly Python people. So if you get a new programming language textbook or online access, this might be one of the kind of things that you want to do to switch over to a new programming language. Because as you get more and more programming languages under your belt, it's easier to learn new ones. And these are the kinds of things that you need to know if you're switching from one language to another. How do I do these functions in this language? We need to know how to declare variables, right? How to declare functions, and how to use the built-in functions. Great job. So that's our to upper and to lower. In this example, they have some really fancy stuff here in this presentation. They want you to think about these two people that are co-presidents of the Gamers at College Club. They've created a website and they want the site to be secure. So Nick would like each member to have a secret login name, and Natalie offers to write a program to achieve this. Unfortunately, Natalie did not do a very good job studying this chapter and doesn't understand the difference between value parameters and reference parameters. So she writes this pseudocode that we're going to look at here. He's going to start out declaring some variables and then prompting, do you want to start? If they say yes, then she's going to ask them to enter the member's first name and last name. And then she's going to call her function secret login, and she's going to pass in the first name and the last name. When that secret login function is done, she's going to print out the member name and ask if they want to enter another. So let's go look at that secret login function. Now, this thing is saying that it's going to accept these parameters as reference. So that means that if it updates them, the update is going to be available to the main. She declares a couple of new variables, login and temp. She sets temp to that first name, which was part 1. Then she does a to lower on that, and adds a couple of asterisks. Then she does a 2 lower on part 2. Well, she sets part 2 basically to the temp variable in lowercase. Are those variables both now the same values? Because we saved part 1 in temp. Oh, wait, never mind. We're saving part 2 and part 1, and then we're going to use temp to switch. So we're kind of switching it up. So she's basically swapped the first name and the last name there. And then the login is going to be that switch, and that's going to be your secret login. Now, when she sees what the display is, she sees that it's displaying her login correctly, that she wanted last name, 2 stars, and then first name. But the member name, but when it gets back to the main, is not printing properly. It should be printing Mary Lamb is her name. So how that could be fixed is don't pass the variables by reference. And then that way they wouldn't be being updated by that subprogram, and they would retain their values. Okay, so in variable processing, the scope of a variable is very important. We know that the scope of a variable depends on where the variable was declared or first referenced when we're using Python. If we're declaring global variables, those are usually declared in the main program at the very top. These are variables that we're going to be able to use in every function, so they can be kind of handy. They're also considered kind of poor programming practice because they make all of our functions dependent on each other. Because if we're all sharing the same variable, now we have to all worry about the same variable. So they're discouraged. Local variables are the variables like we've been using, where they are only available in the function that where they're declared. We can take things further, and if we declare a variable or the first time we use it is within an if statement body, that variable could be local just to that if statement. We may not be able to use it outside of that if statement body. That's why with our Python code, we've been declaring our variables at the beginning of our main or at the beginning of our program so that our scope would be appropriate. We didn't want it to be limited to an if statement area or something along those lines. So as we start creating functions and moving some of our logic out of our main or out of our main program, our variable scope and how we pass that data from one function to another starts being a lot more important. Whenever we're looking at a local variable, remember that the value of a local variable changed in a subprogram should not affect that variable outside of that subprogram. And again, the value of a variable, when it changes elsewhere in a program, a local variable with the same name remains unchanged. So I could have 2 subprograms with using the same variable name, but they are not using the same exact variable in memory. We looked at all of these. Those are our worksheets that we just did. All of those kinds of functions are called built-in functions. When we create a function, it's called a user-defined function. So we want to create more functions so we can get a little bit more practice. One other thing that we need to look at before we're done here is recursion. This is actually a really complex idea, but it's a real simple definition, so it's really easy to remember. A recursive function or subprogram is just one that calls itself. So if I have a menu and I let somebody choose an option from that menu, we'll do this today, and they run that option. When it's done, I could run my menu function again, and it would be recursive because I would be running it over and over from the same place. Oh, not a good explanation. Another place that's recursive is if you're drilling down in your file system on Windows. If you ever thought about that, you go into your C drive, and that uses a program that displays all of the folders and files, right, on your C drive. Then you double click on a folder to drill down. That's going to call that same program again, only this time it's using that folder to display all the information. If you double click on another folder, again, the Windows display folder program, will call itself again to display another level.
So is that like if you're like a point of sale system, like if you finish a sale and it calls it back up after the
Pretty
sale
much, you can
finished?
think about it that way, that it's just recursive, it's going to continue running. We don't know, it could just be a while loop that never ends. It
But
might
there's
be
multiple
implemented a
ways to
different
do it.
way, right? But we can use recursion. The place where recursion comes around a lot is in bill of materials. If I was thinking about real world, you guys will do a lot of math examples of recursion as beginning programmers, but in the real world, I have a product A. Product A is built by product B, C, and D. But I can't just say product A needs product B, C, and D. What does product B need? Maybe I need product 79, 43, and 57. So if I do a bill of materials explosion like that, where I say, okay, product A has these 3 things in it. The first of these things has 7 things in it. One of those has 18 more things. And I keep listing all of that so that they would have a complete list of every little thing they needed to build that. That's a bill of materials explosion. You get that if you buy anything online. If you've ever bought any furniture online that you had to build, you should do that. Because in the instructions, they basically give you a bill of materials explosion. They list every single thing that should be in the box. You should have 2 of these shelves. You should have 16 of these screws, 7 of these screws. So that's a bill of materials explosion, right? And so recursively, it's going to be saying, oh, I need this package of screws. Well, what's in that package of screws? And we're going to keep calling that same function over and over until we get all the way done. So we'll try it with a menu. So in this example, they're using a sum, and they're saying that if our number is 1, then our sum is 1, and we're just going to be done. Otherwise, we're going to update the sum by calling our sum function again and adding more to it. Let's do it with our menu so that it makes more sense. As you can tell with that one, they had to do a couple of slides there. So we can write a program. Let's do it. I've got PyCharm open. Can you open your PyCharm? Or idle. If you're liking idle, that's fine. And I've got this little teeny program I'd like for us to write. And we're just going to calculate a sum of 2 numbers. Kind of like the example of the assignment that you have that's due tonight. Kind of run out of time on that one, but we should have plenty of time today for you to work on it, I think. So I'm going to right-click on my SP19 folder and create a new Python file. And let's call this Chapter 9, Calc Sum Function. And in our calc sum function, I'll put some comments here. Now in our calculation, we're not going to even prompt for any numbers or anything at first, because we just want to do it quickly. So our purpose here is really just to create that function that sums 2 numbers together. So I want to define that function. We're going to call our function calc sum, and we're going to say it needs 2 numbers, num1 and num2. We can actually just use our return keyword and say we just want to return the sum of those 2 numbers. Now this is what I mean by saying that sometimes in our beginning programs, it seems ridiculous to have these functions. It's not doing much. but it's very, very logical because now we've got this separated out and we don't have to worry about it in our main. Now I'm going to declare our main function, and in our main we're going to call our calc sum function, and I'm just going to pass it a couple of numbers. Now it's going to return something, so I need to save the data that it returns. So I'll save it in a variable named sum. And then I'll print out that value of sum. That should be all we need. Let's run it. Oops, mine didn't do anything. How about yours? I got to call that main to make it do something. And now I've got 12. Not a very helpful printout. Let's fix that a little bit. The sum is, and then I'll put my string function to use by converting my sum to a string. That should look a little bit better. Good. Now what I'm doing here is, first of all, for documentation, oftentimes we want that flower box for every single function. So we'll say this is our calc sum function. Its inputs are 2 numbers. Its outputs are the sum of the 2 numbers. Now I went ahead and put the dashed lines around it to show you how you could really emphasize those comments. When you turn in assignments, I would like it if you have comments for each of your functions. This is a good way to do it, where you're saying what the function is, what inputs it requires, and what outputs it supplies. I'm going to copy these comments then to put with our main. And I'll say this is our main function. There are no inputs, and there are no outputs. Now, as a recursive function, a lot of times people in Python like to just call their main again. Oops, no colon there. So what's that going to do? Is it going to give me an infinite loop? Let's try it. I'm going to save first. Ah, Python caught it. So I did loop for quite some time. I got a lot of messages out. And then Python said, previous line was repeated like way too much. It saw that I was in a recursion depth issue. So I had about 1,000 versions of my main method running. Let's copy this and take it to that visualizer site, because I want to show you that recursion in action. We'll see if we break their site. I don't want to, but we could. So if I try to visualize execution here, oh, it caught it. Did it catch yours? Okay. They didn't want us to kill their server, so that's good. So what we would see is every time when we first started our program, our main would be loaded into memory. I'm going to put it down at the bottom because that's kind of the way it is. it would start down here, and it would call our calc sum, and the calc sum would return. So just the main would be left in memory. Then it would call itself, and now another version of our main is in memory. It would call its calc sum would return, and then that main would call itself again. So now we have another version of the main in memory. It would call calc sum would get done, and it would print it out, and then it would call itself again, and we'd have another version of main in memory. So that's recursion internally. We're getting all of these instances in memory. Now, if this main got done and did some sort of return, then it would relinquish control, be eliminated from memory, and this main would get to take back up again. If it somehow finished, then it would relinquish control, get eliminated from memory, and we would return to the second main we called. When it finally gets done, relinquishes control, we would be back to our first one, which would hopefully get done. Now, we didn't do this process correctly in our recursion. We just created a never-ending loop. So that's why we got rejected. So that's okay. We can handle that. Just wanted to show you that you can do that. And sometimes in Python, that's a good way to solve a problem. If you have a loop or something like that where you're asking the user if they want to continue, you might like to do it by just calling your main again and starting over the whole process. So this looks really good, but I'd like to make it a little bit more like the one that you have that's due tonight. So let's create another function for a menu. I'm going to put it up here at the top of our functions because it's kind of the first thing that'll happen. So in our menu function, let's print out some options and say, would you like to now remember we could use that \n to go to a new line in our string, but it's kind of easier for other people to follow along if we just had separate print statements. Would you like to, one, add two numbers, and then I'll put two, subtract two numbers. Now in your assignment, you have to have like, I think 3 options. So yours menu would have to have a little bit more than this. But now that I've got these options set, I can create a variable, I'll call it choice, and let's load that using an input statement. And we'll say something here like make your selection. Then if our choice, we want to make sure it's equal to 1 or 2. So let's say if choice equals 1, why would I put double quotes around that number 1? Because it's a string, exactly. I did not convert it to an integer when I did my input statement. So it's still a string, which is fine because I'm just doing this menu system. So if the choice equals 1, we're going to call our calc sum function, and we'll pass some numbers. Now these numbers are just kind of, as I would refer to it, hard-coded in our code for testing. In reality, we would want to prompt the user for these 2 numbers to use. But for now, we're just going to put something in so that we can simulate this functionality. So then I can use our elif and say elif choice equals 2. If choice equals 2, I want to call a method called calc diff. Now that method or function doesn't exist yet, So we're getting an error there. And I'm going to put one more else and print out invalid selection. And then recursively, we'll run our menu again. I guess we could just put that where it runs no matter what. So we'll process their choice, and then we'll display the menu again. Now we saw from our recursion being rejected by that visualizer site, it can be pretty resource intensive. So we'll see if this is a problem for us. Now I need to do a couple more things. First of all, I need some documentation for my new menu function. So I'll copy that. And I'm going to change it. This is my menu. It has no inputs, no outputs. But it is functionally, logically, all on its own. Okay, so now I need to create my calc diff function. And it's going to be just like my calc sum function. So I'll put it right underneath. I have two numbers as input, and my output is going to be the difference between the two numbers. So I'll declare my function, calc diff, and it needs two numbers, num1 and num2. And all we're going to do in this one is return num1 minus num2. So we need to really change our main a lot. So in our main, before we were just calling our calc sum and then doing this print, that's not going to work at all. So I'm going to change it, to copy to call, sorry, our menu. Now I'm going to cut this next line of code, the print statement. And we could put that in our menu. Let's try it. I'm going to paste it right there. Now I need to capture that sum that gets returned by my calc sum method, and I'll put it in my sum variable. I need to do the same thing with my difference. So I'll create a variable diff to hold the difference and create a print statement afterwards. Now looking at our menu function, we could also split this apart a little bit more. We could create a function that processes choice 1, that does these 2 lines of code, and we could create another function that processes choice 2 that does these 2 lines of code. That would be a logical place for us to create additional functions. But I don't want to run out of time, so let's run this one and see how we're doing. So our menu comes up. Would you like to add 2 numbers or subtract 2 numbers? I'm going to choose 1, and it tells me the sum is, and then redisplays my menu. I'll go ahead and say I want to subtract, and it tells me the difference is. Now I want to make an invalid selection. So we got our message, invalid selection, and then the menu displays again. Is everybody's working okay? Let me put that code back up so you can see. Tell me what you need. Okay. It should look like this. You see it? Okay, let me know if there's something else.
The conversion to the string isn't working properly because sum is a built-in function and diff isn't the variable that we.
It's mad at us about those variable names.
Mine's mad about my line 10. My line 10 is exactly like
Look at the line above it and see if there's something weird.
well, it wasn't just like yours, but now it is. What is it?
So we don't like those variable names, huh?
Because
So,
Let's make it
mine
different.
says process finish x = 0.
So down at the very bottom, make sure you call your main. I'm going to change those variable names. Now, I'm going to make my sum variable be like my sum. And then we'll make our diff be like my diff. So we don't make it mad. No, it doesn't like my spelling. Shut up, PyCharm. Tell me all sorts of weird things. I need those redundant parentheses. Thank you very much. Now try and run it again and make sure it's all working. Since you made some changes, we changed those variable names, we could have trouble. So I want to add in our main. The what? It worked? Is everybody's working? Let's get them fixed. Okay, look at your neighbors, help them. Let's get it all fixed before we do anything else to it.
yeah, my issue was I wasn't paying enough attention. I didn't see that you set the variable names in front of the function, so I just had the function sitting there, and I yeah, because I didn't have that equals in front of it. I had calls to this.
Yeah, mine didn't care about those variables. It just said that I was using shadow versions of it. It was like, I see these. I'll use it.
Alright, now it's working.
So how could we? Prompt our user for our two numbers. What I'm thinking is that our menu is probably the right place, but we need to create an input function. So where do we want to put it? Let's put it right above our menu. So I want to make sure that I don't separate my menu from its comments. So I'll press enter to move it down a few lines. And I'm just going to put a new comment in for this one. And we'll call it INP data. Right now we won't expect any inputs, and our outputs will be the user's number. So for this function, we said we weren't going to need any input, so I'll leave the data between our parentheses blank. But I want to prompt for a number. So I'm just going to do a return statement and say I want to use the input command and say, please enter a number. Now, do we want to do anything to that number? Do we want to convert it to an integer? Since we're going to be using it for all that math stuff, probably should.
Do you want to ask for two numbers? Or we have both numbers for the...
We could. Or we could just call our function twice. So either way is fine. I'm going to put the call, though, in our menu. And I'm going to assume that we could have functions that only need one number, like the square root function that you guys would have for your program, and your program, I think, only needs one. So we'll just use that function so that it'll be closer to what you need. So what I'm going to do is declare a variable num1 and set it equal to whatever I get returned from that input data function. So instead of putting the input call just embedded here, I've created a function to hold it, and then I can use that. So I could actually do the same thing, num2 equals INP data, and then I need to change my calc sum to use num1 and num2 as variables instead of those hard-coded values that I was using before. Let's add some comments here. Get the first number. Get the second number. Call our calc with the variables. So I have a question for you. Do I need this my sum variable? Is there a way that I could combine these two lines of code into one?
Is there a way to have it print the like result of the call to function as one line?
Uh-huh, yeah. So that's what I was thinking. Maybe we don't need that my sum variable, because if we just place this call to the function here, then we could get away from needing that variable. So when we combine lines of code like this, could we also do the same thing with these? We could say num1, we call our input data function, and to get num2, we call our input data function. Then we don't need any of these. Whoops. So two ways to think about it. When I'm programming and showing people, I usually use this kind of longer, more strung out type syntax, because I want you to see that calling this function returns this data that we're going to save in this variable. If we push everything all together like this, it's a little bit harder to see what's happening, but this is perfectly valid. And so I kind of kid about it that this is sort of the engineer's way of doing things, because people that have engineering type brains that are really good at inventions and building things hate all this extra stuff. They want to smoosh everything down as much as humanly possible. They hate spaces. They don't even want spaces between their plus signs and stuff. That's okay. But as a programmer, I like to spread it all out, have a little bit more white space, make it simpler for everybody to kind of see. But you have that choice. So you can do it either way. Just remember that once I've created this function now, I have this flexibility of just using it right there in line in my code. So that's given us a lot of stuff here to think about. I want to save this. And let's create one new one. I'm going to create a new Python file, call it chapter 9, Builtin Functions. And when we were talking about those functions, just a few minutes ago, we said we have to use this statement, import math, to get the math library. That's going to give us access to those math built-in functions. And then I want to create a variable, our float, and let's make it equal to 34.53. So that should round up to 35, right? Then let's print out str.ceiling for our float and see what it says. I'm thinking it's going to say it hates this syntax, but we'll try it. Yeah, It does not like that. So we want to do our float dot ceiling with no parameters within the parentheses. Am I doing it wrong? You guys told me what it was. Oh, CEIL. I'm making it too long. I'm sorry. I'm going to try that original syntax and see if it works because I just had it wrong there. It'd drive you crazy. Nope.
Can it not print it because you didn't convert it back to a string? Convert it to a string.
Maybe. Try it. I'm staring at it going, why don't you work? Float object has no attribute seal. So what we have to do is convert it to a string first. Is that right? Float. Yeah, we need, that's what we need to do. So do you have it?
Yeah, I've got it.
Someone take this thing over for me. Share yours because I've become ceiling incapable this morning.
Yeah. Trying to figure out how to.
You had to set in the option, so that's okay. You're all right. You won't be able to zoom in much. So do you see how he has it? He has math.ceil, and then within parentheses is the parameter is our float. And then he's converting that output to a string. So what are you getting there? 35. So notice it rounding up. And so I'm not exactly sure about the verbiage that we were encoding on the internet, but remember the ceiling basically rounds up to an integer. Now change your R float to 34.43 and try that ceiling function. What should it do then?
Mine looks almost identical. To me, it looks identical, and I'm getting it here.
Okay.
It's saying that unresolved reference our float, so even though it looks Oh, yeah, no, never mind. It was a capitalization issue. My variable didn't have capitalization in it.
So now he's got 34.43, but the ceiling still went up. So remember, the ceiling is not round, right? It's basically take this float and make it into an integer that's greater than this number. So let's try that floor function with it and see how that's different. Can I get mine to work? I don't know. That looks good. So I'm going to copy it and make it math.floor. I'll add that to my print statement. So I'll put some spaces there to make it a little bit more readable. Basically, what we have is floor just chops off the decimal, right? And it returns the integer basically without any of the decimal places. The ceiling rounds or goes up to the next integer and chops off the decimal place before it returns it. So did we find any sort of round function? That wasn't on our list. Let's see if we can find one. Python round function. And it is round. So let's try it, because that one should actually be dependent on our data. So right now, my number is 34.53. So my round value should be the same as my ceiling value. Great. Well, it's in the Python standard library, so I don't need the math dot. Now, if I change my float to be less than the 0.5 required to round, it should be the same as my floor value. One last thing that's always a killer on this unit exam. The unit exam on Wednesday should be available to you. You should have a practice test just like the other ones. Make sure you're going through the practice test. The questions that usually get people on this exam have to do with the ceiling and the floor. So I think this is really good for us to practice it, get an idea down. The other ones that can be really awful are the ones that have to do with random numbers. When I generate random numbers, we start out with a seed value. So if I have a random number generator, A, it's going to use whatever seed value it was given to generate random numbers. This is going to be like its input to whatever kind of weirdo algorithm it has to try to generate random numbers. Now, if I have another random number generator, random B, it's also going to have its own seed value. If they were given the same seed value, they're going to generate the same random numbers pretty much, because the seed value needs to be really unique to actually generate numbers that are randomized. Normally for this seed value, people use like the current time, but we use the current time like all the way out to a millisecond, so that it's a pretty unique value, and it's a really long number. You know, day, month, year, hour, minute, second, millisecond. So it gets pretty long. So we don't have to worry too much about our seed numbers. And that's true in Python. It takes care of that seeding of that random number for us, so we don't have to worry about it, and it's really good about giving us random numbers. Now, if I were in this situation where I had two random number generators and they were given the same seed value and they were producing basically the same numbers, those would be called pseudo-random. Meaning they look like they're random numbers. They came out of a random number generator, but they're not really random because that seed value was the same. So that's what we're talking about here. If these were seeded properly, then we should get real random numbers out of them. Now, the other thing about a random number is whenever a programming language generates a random number, there's sort of a standard. And that is that that random number is going to be somewhere between 0 and 1, exclusive. So it's going to be a decimal value. So like 0.24. That would be a number between 0 and 1, exclusive. It does not include 0. or 1, only the numbers between 0 and 1. So 0.24, we haven't seen those numbers in Python. We've seen like 1 and 57, and we've only done it a little bit. That's because Python internally is going to multiply that by 100 for us to give us a value of 24. Okay? So with Python, whenever we say that we want the next random integer, in our parameters, we can say what the values are that we want those random numbers to be within. I want my random number to be within the value 100 to 200. I can do that. Now, if I said that I wanted my random number to be between the value of 1 and 5, Python's going to take care of that for me. I'm not going to have to worry about it at all. So where things come into problems is when I've got to find some of them. See if we can find one here in the practice test so I can show you. Yay, question 1. There are quite a few of them, that's what I want to show you. So here they say, if the number equals 4, what possible numbers can result from this value? First of all, we're generating a random number and multiplying that decimal value by 10. So if you say we've got a random number between 0 and 1, and we multiply it by 10, it's just going to have one integer to the left of the decimal place, right? It's not going to have 2, so it's just going to have 1. And then we're going to add this number to it. So what possible values could we get? We know that we shouldn't be getting 0 out. Let's just click grade and see what it wants so we can look at it. So how would it get that? Because our random number that we return is going to be multiplied by 10.
Is it because it's using floor, so sometimes it's rounding it, or it's going down to 0 after?
Yes. So our floor is taking it down and getting rid of that decimal place. So we could theoretically end up with 0, and then we add number to it. So that's why that first value we could have is 4. Now, if we weren't adding number to it, the first number we could have would be that 0 because of that floor method. So look really closely at these kinds of questions in the practice exam and try some code. Now, it's hard for us to replicate some of these questions with Python because Python takes care of so much of this for us that we don't have to worry about these kinds of things happening. But we know that if we ended up with a random number of, 0.9, and we multiply it by 10, then we're going to have 9. We add our number, we could get up to 13. So you could almost kind of guess this question's answer by looking at the value of that number variable and what its range is. Now the next one, notice it's talking about the ceiling statement, the floor statement. So there's just a whole lot of emphasis on those built-in functions as you look at your exam. Remember that functions that we create are user-defined functions. Functions that we have available to us through the system libraries are the built-in functions. So I think we've practiced pretty good for our functions. As I mentioned, you might still have that feeling like, I would like to practice more, I would like to practice more, and that's true. But then we'd never ever get done. Questions about it before we stop? I wanted you guys to have more time for lab time. I apologize for that. Please email me if you're running into trouble with this one, because I want you to be successful on it, and I'll help you try to get through it if you're having some sort of issue. Should be real close to that sample that we just did. But it is definitely going to be a little different.